set up this diagram for the SR Flip Flop, trying to use the snap circuit set, but I hadn't anticipated just how hard it was going to be just to take that visualization there and put it on the board. One thing I noticed is that this node here is connected to the top of that transistor, this resistor, and one end of the light bulb. How do I get that node? I think I'm going to use a 4 partner on that, and I'll set up 2 of those. Okay, here's what I meant by 4 partner. I just meant connecting up one of those there and one of those there with the NPN transistor on both of them. Okay, now I've stuck a switch in there in the top of the circuit. So the top of the circuit is connected to the batteries now. And I'm connecting a set reset switch to the base of each of these guys. Now you can see here that the emitter is connected to each switch. So I'm going to do that with like that there, and that there. And the last little bit has to be done with just a regular wire, which means that guy has to be connected to, wait a second, on the switch we've got the resistor here connected to the base there, so that means the base there is connected to the resistor here, and then we'll have the base over here connected to the resistor there. Now I have to connect the batteries together and then connect the ground of the batteries across here. And I grounded it, and now I flip the switch on. I probably should have recorded my prior reaction, which was no way it works. But so I can prove that I did it once because I have it on film. All right. Set, reset, flip, flop. Okay. Okay, so what happens? When I turn it on, the right-hand light comes on. Now, is that consistent? Will the right-hand light come on consistently? Probably. And the reason that the right-hand light comes on regularly is probably because the circuit is not entirely symmetric. And the reason it's not symmetric is because there's more of a path to go through this direction than there is through this direction. And therefore there's more resistance going through this direction. So this light's going to come on when I first turn it on because the resistance is greater on this side. But when I flip, is it this switch? When I flip this switch, this emitter is shorted to this base. And when that happens, there's no voltage difference between here and here. And it turns off basically turns off this transistor, so current can't flow through it. In the meantime, this base to emitter is forward biased because we've got this voltage coming through from the batteries through this resistor down I think is there a resistance between them? Yes. Wait. In the diagram, it's easier to see in the diagram over here. It's coming down this way through this resistor and down through here. When this is shorted, then there's no voltage across that, which turns this off. Or when it's not shorted, it's just easier for the path that's already developed. I'm not sure if I'm explaining that well, but at least I got the thing to work, so that's what I wanted. Who knows why it works? It just does. So now we can make a computer out of it, especially if we miniaturize these a whole lot. And you'll notice, if you actually look down at it, there's this little black thing right here. That's the actual transistor. All of this is just a bunch of extra markings.